So this next slide addresses the question why air pollution is a major environmental issue. Number one, we start with the expansion of industrialization, meaning the expansion of factories and manufacturing environments versus the small scale stuff that used to happen when we were more of an agricultural society. That doesn't mean that we didn't have pollution and things like that when we were an agricultural society. Obviously, methane gases from cows and animals are a big concern. There was also a concern with, what did people do with garbage? We didn't have dumps. We burned our garbage back in agricultural times in the 1800s and earlier. Living in cities, right? There was tremendous pollution within cities, even without manufacturing. But the expansion of industrialization by increasing the number of plants that are out there making products and services and what that looks like in terms of the impact on the environment is tremendous. It has gone from, a nominal impact to a tremendous impact, on the environment in terms of pollution and things like that. When there's air pollution, it harms our vegetation. Things like acid rain and the which is rain that comes through pollution that has lots of chemicals and metals in it, and that harms vegetation. Our agricultural yields go down. We're not able to produce the same amount of food that we did before, creating problems for people. And other issues, corrosion and destruction of exposed construction materials. And so when we see corrosion of building materials out there, concrete, wood, roofs, those sorts of things, are the heavy pollution can have a real detrimental impact on the house that you live in. And for many of us, we don't understand this. Living kind of where we do here in Southern Illinois, there's a lot of farmland around us. Even in St. Louis, it's not a heavy pollution-based city, different than being in Chicago or New York. And I grew up near a town called Elizabeth, New Jersey. It's actually the town I was born in, even though I didn't grow up there. And Elizabeth, New Jersey had a lot of oil refineries around it, very similar to Roxana. But think about it, Roxana on steroids, right? There were a lot of refineries and a lot of pollutants in the air, and at a time when we didn't have concern for pollutants. And I always would drive around the community and I would look at the roofing tiles and looking at the wood walls and the aluminum siding, and everything was very corroded and destroyed. It wore down faster. Like the roofing materials would not last as long in those environments as they would in an area, say here where I live in Troy, Illinois. My roof could last me 20 years and it would be significantly less if you lived in those areas. So exposed construction material can wear down. And then also just look at the impact on, concrete and the erosion of concrete, which when that starts to disintegrate, it creates foundational problems for many buildings, and on trees and wood. And so when we have wood that's already weakened because of pollution exposure, it can create, concerns. Then we have the harm to health and life. And I am a 9/11 survivor. I can't remember if I've mentioned that to you all. And I was exposed to horrible pollution and chemicals when I was running for my life on 9/11 and trying to escape the debris from the towers falling. And I have since then had problems with laryngitis, bronchitis, and asthma. I have a cough variant asthma, and I have to be careful. This is why this cold that I've had since December is still weighing on me. It's been almost 2 months. And there's not much we can do to make it go away. And at least I don't sound hoarse like I did before, but it's still a concern. It's still an issue in my body. So, that's just one example of the impact that I had, in breathing, a very concentrated pollution. Imagine even if you didn't have an exposure like I did on 9/11, but it was something that happened over your lifetime, you're going to have significant issues and significant health concerns because that is still an additive effect. It's like smoking, right? We know smoking has a problem when it comes to our lungs, even vaping. So those of you vaping, even vaping creates problems for your lungs. Maybe less so than smoking cigarettes straight or with or without a filter, but it still creates health problems in terms of your lungs. And so if we know, right, that kind of exposure, you know, from smoking or vaping is creating problems for us, you can imagine with air pollution what kind of problems that has, because there's all sorts of chemicals, just like there are in vaping and cigarettes, and it's the same sort of pollutants that are out there in the air that we're breathing. And then ozone destruction. We realized that a lot of spray aerosols back, 20, 30, maybe 40 years ago, that spray aerosols were creating a depletion of our ozone layer. And our ozone layer insulates us and protects us, right? So having an ozone makes sure that when the sun hits us, that we're not baked. The temperatures rise when we destroy that protection layer that's around us. And there was when the ozone starts to deplete, temperatures start to rise, and that's where the sort of the greenhouse effects come into play. That ozone helps us to stay at a managed temperature. So the ozone depletion is the thing that creates the problem for us. So what are some of those major contributors to global climate change? Notice we don't call it, global warming, but more climate change, because areas where it should be cold, it's warm. Area where it's warm is cold. So we're seeing weird fluctuations in the way the climate is behaving. So it's not about it necessarily getting warmer. Our winters will get colder. Our summers will get hotter. And areas where it should be warm, it's cold. Areas where it's cold, it should be warm, are getting warm. So greenhouse gases, right? Carbon dioxide, nitrous oxide, methane, chlorofluorocarbons. The chlorofluorocarbons are the things that ate away at our ozone layer, creating the greenhouse gases and heating up our environment and heating up our atmosphere much more than it needed to. And then add in fossil fuels, which also add to the carbon dioxide levels. That is the natural output of burning fossil fuels. It raises carbon dioxide levels and creates that warming, increases the warming effect. Like I said, there are normal fluctuations, right, in the way temperatures change over time, depending on our rotation, depending on the sun, all sorts of things. There's many, many variables involved. But what we are doing with having fossil fuels and burning them and increasing carbon dioxide in the environment is we are making the climate change far worse than it should be naturally. So what is the effect of climate change at the end of the day? We see a decrease in safe drinking waters. We already see this in the Southwest, where the Colorado River and its tributaries and its lakes that are associated with it are at scary low levels. There is a belief that the Great Salt Lake will disappear soon, as will the Dead Sea. Lots of stuff about that in the news lately. So safe drinking water goes away. Agricultural yields will start to go down. We won't be able to feed people because our water will not be safe, and therefore that water that we absolutely need to survive, we need water, will go away, and the what we need to grow, we won't even be able to use it for irrigation to grow things. So it's a horrible cycle, right, going down. We'll start to see more natural disasters, and again, we'll see droughts, and we'll see weird floods, and I don't think any of this will necessarily have an impact on things like earthquakes, but it has an impact on the increase in volume of hurricanes and tornadoes, weather-related issues. And so all these natural disasters are going to have an impact on our life and safety here on Earth. And then increases in diseases. We're going to start to see, more lung issues, more cancers, things like that. What are the contributing factors to the problem of solving global warming? Well, there are three basic ones: technological, political, and economic. And we will, and with those, the technological means we need to really make sure we manage greenhouse gases in a better way. We need to reduce it tremendously. Um, we need to make global pledges across countries to do better in terms of the environment. We need to make sure economically that our main source of greenhouse gas emissions through power generation, industrial processes, transportation, and farming are better managed, and so that we can find alternative sources of energy generation that aren't going to harm the environment. And solar does not harm the environment in the same way. Yes, there is a cost in building the panels, but the opportunity cost is significantly low, and we manage that. Ozone depletion and acid rain. Ozone depletion means that the gases in the atmosphere are broken down by other gases, by chlorofluorocarbons, as I said, and these deplete the ozone, which creates that greenhouse effect. And then the acid rain is when we burn coal and other things with high levels of sulfur, it's released into the air. And then when the rain comes through that in the atmosphere, it comes through the rain and it pollutes our land. And then lastly, what other pollutants are of concern to us? Well, airborne toxin, um, um, which is what killed those people in Bhopal, India. Over 2,000 people died there. Methyl isocyanate, for example, is one of those concerns. So those pollutants done from chemical manufacturing create issues. And then also whatever happens from auto gas emissions and industrial processes. So um, seeing more electric cars on the road, I think is a good thing, because we have less auto emissions out there. And so we're hoping that with people put more money into, electric cars, and we can get longer distances that people can drive using electric cars. That's the hope. So the next bunch of slides are all figures from the textbook, but these give you a good idea of what's going on. This first one, atmospheric carbon dioxide at the Mauna Loa Observatory. And Mauna Loa is in Hawaii, and it is looking at the carbon dioxide in the Pacific arena, the Pacific Rim. And as you can see here from the label, it says the figure represents the atmospheric carbon dioxide records from 1956 to 2015, indicating an average increase each year of a half a percentage point, or 2 parts per million, of carbon dioxide in the environment. And so what we're seeing is this steady increase from where it says here sort of 1960 in the lower left-hand corner to sort of way past 2010, I guess 2015, in the upper right-hand corner, what that increase is in terms of carbon dioxide. And, there's manufacturing, of course. It's some manufacturing in the Hawaiian Islands. There is some, and there's certainly tons of agriculture because of the plantations, the pineapple plantations and things like that. And so it's capturing sort of the generalized airflow across the Pacific, and that airflow captures the United States, it captures Russia, it captures Asia, because winds blow all across the planet, and so wherever there's an increase in carbon dioxide, we start to see those increases in reflected in the measurements that are taken, for example, here on the Mauna Loa Observatory. On this slide, we're looking at over the last sort of 2,000 years, greenhouse gas concentrations, and we look at carbon dioxide and methane, which is the CH4, and then nitrous oxide, which is N2O. And we start to see the increases as we became more industrialized in the late 1800s, increasing to where it is now in 2000 and beyond. And again, how do we know this? How do we know what happened over 2,000 years? Well, we can do testing on layers of sedimentary rock, and vegetation and trees and all sorts of things. We can start to see what those levels are based on what's captured in fossils and things like that. This is all like hardcore science, which I love but have not studied hard since I was an undergrad back in the 80s. So we can capture and see carbon dioxide, methane, and nitrous oxide in its impact here on plant life and animal life, and rocks formation and sedimentary rocks and things like that. So this gives you an example of ice core records from a couple of different locations, Vostok and Antarctica, looking at the variation of carbon dioxide. And one way that we can monitor carbon dioxide is doing ice samples, right? Because, air quality is locked in ice, and then we can look at that ice and take samples of it, and we can see what the concentrations are. And as I've said, right, there are normal fluctuations. Fluctuations will happen, but what we're seeing is that increase, the increase that's going on at the higher levels, showing that there's a rapid rise in the parts per million of CO2. This looks at global temperatures over time from the late 1800s to 2015, I believe, or 2013, I think, 2013 or 2015. And we can see, again, there are always fluctuations in CO2, natural fluctuations that happen, natural temperature fluctuations that happen. But what we're seeing is, as the rise in industrialization occurs, as the rise in CO2 concentration occurs, the temperature, which is that yellow line across the middle, the temperature goes up. And we're seeing higher average global temperatures because of the higher levels of CO2 concentration in the air. And this is very similar to the previous slide, which is really just looking at decade averages versus years. And the same, obviously the same graph works, that the temperature change has gone up tremendously on average. And we saw with the O2 concentration, particularly from 2001 to 2012, every year is warmer than the 1990 average. It's going up and up and up and up and up. So it is a tremendous concern. This is real hard data. This is real factual data. That global temperature changes are really creating problems for us. As temperatures rise, Arctic waters are rising. We're seeing a lot more erosion. We're seeing water levels rise. Beachfront communities will no longer be beachfront. They'll be underwater in due time. Not today, not tomorrow, maybe not in the next 20 years, but we're starting to see those changes little by little.